Good morning. In this lecture video, I'm going to explain pin description of 8051 microcontroller. It is a 40 pin IC. So this is the pin diagram. It is a 40 pin IC. In this first for pin number 40 is VCC and pin number 20 is ground. VCC means it requires plus 5 volt supply and ground means here we are connecting into negative voltage or a ground pin. And pin number 1 to 8 are port 1 pins, that is port 1.0, 1.1, 1.2, 3, 4, 5, 6, 7. I mean pin number 1 to 8 are used for pin number port pin 1.0 to 1.7. And here the description we can say port 0 pins used to interface, sorry, port 1 pins not 0, 1 pins used to interface peripherals. And then pin number 9 is RST pin. RST means reset pin. Reset pin resets the activity of microcontroller. That means execution starts from the address 00H. So hence we are expecting the first stop code must be stored at the address 00H. Okay. And then pin number 10 to 17 are port 3 pins. In bracket we return another function, that is RxD TXD, that is called alternate function. Port 1 does not have alternate function, it is alone used for input or output, but port 3 pins have alternate functions. Let's see, pin number 10 to 17 are named as P3.0 to P3.7. They can be used as a port 3 pins as in input or output to interface the peripheral, or alternate functions. Pin number 10 is RxD, used to receive data serially in serial communication. So if you receive the data from external device, that data will be received serially through this RxD pin, and this RxD pin will be connected to TXD of the external device. And pin number 11 is TXD. Through this pin, microcontroller send the data serially. So this pin will be connected to RxD pin of external device. So this is used to transmit the data serially. And then pin number 12, INT0 complement, means active low signal. It is an external interrupt 0. It is active low pin used to interrupt the sequential flow of execution. As you know, interrupt is an event which alters the normal sequential flow of execution. If this pin get activated, it occurs the interrupt. I mean interrupt 0 is occurred. So there it will go to the interrupt service routine. There it executes the required action, and then it will come back and continues the program execution. This is the external pin, interrupt pin. And pin number 13 is same external interrupt pin, active low, used to interrupt the sequential flow of execution. And pin number 14, T0, timer 0, provides external pulses for counter 0. As you know, we have two timer bar counters, 16-bit timer bar counter. I mean they can be configured as a timer as well as a counter. So if we configure as a counter is to count the external events. That external events or external pulses are received through T0 pin, that is pin number 14 for counter 0. Similarly, for counter 1, we receive external counting pulses for counter 1 through T1 pin, that is pin number 15. And pin number 16, the alternate function is WR bar write, I mean write control pin. It is active low, used to write the external data RAM. As you know, a RAM can be read or write. If microcontroller wants to write the data into memory, first it has to assert the signal, a low signal on WR pin. Thereby the data available in the data bus will be copied to external RAM. And similarly, to read the external RAM, we need a read control pin, that is RD bar, pin number 17. Again, it is active low, used to read the external data RAM. So microcontroller has to assert the low signal on RD bar, thereby the data from memory is copied into data bus, thereby it is available to the 8051 microcontroller. And then next two pin, that is XTAL1 and XTAL2, pin number 18 and 19. So these are provided for external frequency sources, as you know I have explained in oscillator and timing of 8051. To this pin we connect external frequency source, that is most frequently used is crystal oscillator through capacitors. And then pin number 21 to 28, P2.0 to P2.7, in bracket which is written A8, A9 up to A15, that is alternate function. So pin number 21 to 28 are named as P2.0 to P2.7, or they can be named as A8 to A15, that means alternate function. So these pins can be used to interface peripherals and can be used as a IO or I-adder address pins for external memory. And then pin number 29, PSEN bar, program store enable. PSEN means program store enable, and it is active low. It is an output pin. Output pin means it output of a microcontroller. Output of a microcontroller. So whenever microcontroller wants to read external ROM, it has to assert a signal on PSEN bar. So use it to access external RAM. It is connected to enable pin of ROM chip or chip select pin. Enable pin or chip select pin. And to access the program code, I mean external from the external memory, external access must be grounded. EA means external access. Then PSEN will go low and enables external RAM to place the byte of program code on the data bus. And next pin is ALE bar program complemented. That means here here we have written 8051 in bracket 8031. That means both pin configuration are compatible. Only two pins are different. And here 8031 is ROM-less. It doesn't have built-in ROM, but it has built-in RAM. 8051 has built-in RAM, but 8031 doesn't have built-in RAM. ROM-less, we call it a ROM-less. Only two pins are changes. That is pin number 30. In 8051 it is used as a ALE. In 8031 it is used as a program control pin. Okay. So if it is ALE, then it is address latch enable, is an output pin and is active high, used for demultiplexing address and data lines. So when it is 1, CPU uses port 0 as address lines, and if it is 0, used as a data lines. For 8031 it is program pulse input during EEPROM or RAM programming. So to program, as I said, 8031 is in ROM-less, so we go for external program memory. To program that external memory, we use this as a program pulse. And next pin, EA bar VPP. I mean, it is EA bar for 8051 and VPP bar for 8031. External access input pin and must be connected to either VCC or ground. To VCC means indicates program stored in the on-chip RAM. If it is ground means indicates program has to be accessed from external memory. And for 8031, it is a programming voltage. Programming voltage used to supply programming voltage of 12 volt to external RAM. EEPROM is erasable programmable read-only memory. And the remaining pins, that is pin number 32 to 39, they are named as a P0, P0.0 to P0.7, or alternate function is AD0, address bar data 0 to address bar data 7. So these pins can be used to interface the peripherals, or alternate, they are used as a address bar data pins. I mean, in the beginning of the machine cycle, they used as a address pins, and in the later part of the machine cycle, they used as a data pins, bidirectional data pins. So this is about pin description of 8051. Uh, yeah, fine. So I'll continue in the next video. Thank you.